Okay, so, well, first of all, thank you for being here. Good morning, ladies and gentlemen, and data scientists. Is there any data scientist here in the room? Because I see ladies and gentlemen, but I don't know. Okay, okay, some part of the audience. That's nice. So the title of the talk today is Capturing Value from Big Financial Data. And it's, well, even though this is a big data conference, I wanted basically to focus not so much on the technology. So first of all, this is not a talk about big data, because you all know probably much better than me what technology can do for you, or the different flavors of technology, the different flavors of big data. You all know very well what Hadoop can do and what, I don't know, oh goodness, MongoDB and R and all the packages that you've got available can do for you. So I'm going to try to do something else. I'm going to try to understand why do we want to do all those things, and I want to try to transmit that to you as well. We talk a lot about using neural networks, and we are trying to find out how to do pattern recognition, how to do text mining, speech analytics, speech recognition, and then we try to, with all those tools, we try to detect emotions, and we try to basically transfer to machines the capabilities that we as humans have had for a long time, that nature basically has been doing for a long time. Now, nature was not exploring technologies, was not exploring algorithms, was not exploring data science. Nature was just evolving, and nature came to the conclusion that it needed to do all those things, that emotion detection and that pattern recognition, to do just one thing, which was to maximize biological value. Which is basically you find a partner and you make life go on, right? And these two, they are not a couple, they are friends of mine, but they're not a couple in case they see it and they say something to me. So the thing is, this maximizing biological value is to me, it's like a driver of life, right? Because life had one clear goal, which is to live. And since you have a goal, since you know where your value is, then there are a lot of techniques that you can use to get there. And it's actually quite funny. I don't know if any of you guys have seen a book called Data, A Love Story by some woman named Amy Webb. She was trying online dating to maximize her biological value. And it just didn't work for her at all. And what she was doing then was she hacked, let's say, the online dating algorithm. She created her own system. She created 10 fake male profiles to study women in the online dating sites to find out what were the interesting traits of data that she could use to design her own profile. And she was using all sorts of data science techniques, and it was not big data, okay, it was just a small set, if you want. It was different types of data. So in the end, she also had a clear goal. She also knew before she started setting out to explore all the technologies and all the different possibilities. So basically, we need to extract the right value from data, or we need to extract value from the right data, or we need to extract the right value from the right data. I don't care about the combinations. What I'm not dropping is value. It's key in what I'm going to be saying now. So, okay, which data? What data should I be using? Well, basically, we've been hearing this in several talks during the morning. You can start gathering all the data that you have around you, which is probably a good idea because later on you are going to be willing to use it. Or you can just look at what you already have, because sometimes you already have at your disposal like lots and lots of databases or data sources that you have traditionally not considered to be of interest to your activity. Basically, life is data, so data is surrounding us absolutely everywhere. And in everything that we do and see in our daily lives, we are looking at data points. If you go into the metro system, into the subway, and you put your ticket in there, that's one data point. And then you're making a phone call, that's another data point. And then you receive a parcel at home and you sign that you received it, that's another data point. So basically, it's all lots and lots of things that we can mine to understand reality. But out of all those things, only a very small amount is actually being used. And this is some message that I heard also in the morning in some previous talks. And it is that you really could consider either using more of what you have or just collecting everything that is around you, because later on you are going to be willing to use it. So then, based on this reflection that everything is data, and data can help describe what is going on very well, and if you can describe what is going on very well, then you can probably find a suitable use case for all that description, and then you can find value in that data. You can provide something to someone, or even to your own company. Based on this reflection, we said, okay, we as a bank, we operate a payments network, and we are processing 26 million transactions per day, and this is only the payment transactions in all the geographies where we operate. And there's more data sources that we are using, but we started out all this project by trying to understand what this data could tell us, because all the payment data is basically describing what is going on in reality, because most of what we do involves a payment. So we decided to plot this very simple map. This is like one of the very early examples that we did 2 years ago. We decided to plot this map. This is the street map of Madrid, with the black dots representing the points of sale. And if we remove the map, we would still see mostly the same street layout because of the high density of the data points. So this is basically saying that, yes, this data source is interesting because it's going to be describing what goes on in each and every neighborhood in the city when we look at it at an aggregated level and on several temporal patterns and so on. So then, okay, we've got all this data. How should I approach the problem, right? Should I build a massively scalable system and then reap all the data and then start processing all the data very quickly? Well, we are going to share how we have been approaching this problem from our side. And the thing is, we started very small. We started only with that map, almost, with that map and plotting the dots and understanding what this was about. Because starting small, and this is also something that was said earlier in the morning, basically everything I'm going to say has been already said. If you start small, it's much more easy, it's much more feasible for your company or maybe, I don't know, for your resources to actually accept that you're going to spend some time. So you have to explore first. You have to try. Maybe you still don't know what you want to do. So if you don't know what you want to do, you need to explore first before you go full scale with this. And once you explore, then you learn. And if you learn a little bit and then you understand a little bit better, then you can start convincing people in your company that this is something that you need to do. And if you convince people in your company that this is something that you need to do, then you can explore with more money, basically. And if you explore with more money, then you basically learn more. And then once this starts rolling, then you can start building exciting products or projects, which is kind of the stage where we are at. But I wanted to say that even though we started small, now it's growing bigger and bigger at BBVA, all the data-based products and analysis and so on. Even then, every time that we start some new project, we always start out by exploring and by doing it small. Okay, so even though now we have bigger systems and we have lots of data that we have already collected, we would still have this approach of let's do this small experiment. So I'm going to talk to you now about some of the projects that we are working on. We've got like 3 main lines of work mostly, or 2, or it depends on how you look at it. But basically what we do is we try to understand how all the data that we have, the data sources coming from payments or data sources coming from account movements or data sources coming from basically the bank's activity. We're trying to understand how can we use all that to improve our current lines of business. So we have applications in risk and fraud, and we have applications in credit credit access, which is what I'm going to be talking about. And later on, we will see other lines of work which have to do more with generating value for third parties. So the capabilities that we have, how can we build something that is useful to someone else, not just to us. But anyway, going back to the credit access point, basically, when a business comes and enters the door at a bank branch and says, "Hello, I want a loan. This is my accounting," and then you look at the accounting, and sometimes it looks good, sometimes it doesn't look so good. But the problem is the accounting probably does not reflect the true reality of the business or the true reality of the, let's say, environment of the business. So it's not just your cold numbers. It's not the same to be located there, right, at the heart of your commercial city center, where there's lots and lots of people going around, where there's, I don't know, lots of activity that you might benefit from. It's not the same being there as being in the outskirts where nothing is happening, and actually maybe it's an area of town that is decaying and so on. So what we are trying to understand is how can we use the data that we have of payments, basically, to improve this credit risk scoring that we have. And I'm going to show you a very simple example that we did also, one of the earliest experiments. So you might know it already. This is, we're going to plot in our horizontal axis the Paseo de Gracia, which is the main commercial street in Barcelona. And what we are going to do is plot all the transaction amounts, all the number of transactions, sorry, in every store in the street, at each place in the street, at each number in the street, right? And we are stacking different stores if they are placed in the same number, and very quickly you see this very big bar in the center, and it's really capturing your eye, and you say, oh, this is actually capturing 15% of all the transactions that take place in this street. And this is really relevant because well, before you could not know really what's your street market share. So this is, to start with, this is a very interesting information even for this store. But what we want to look at is how this store shares customers with the rest of the street. And it turns out that it shares 40% of its customers. The shop that drives more traffic is sharing actually a lot. There's only one shop that shared 43%, I think, so this comes second in the street. And it's let's say, acting as a central hub and then distributing flows of money into other stores. So it's not the same if you are a store, if you're a small shop that is actually sharing customers with this or is close by, and then you could benefit from all the dynamics, all the commercial dynamics that derive from these relationships. It's not the same to be there as being anywhere else. And actually we could look at the trends in this sharing, and we could look at the trends over time in the spending in the area, sorry, to try to determine if your business is going to be doing well or not in the near future, to try to assess better if we can give you some, if we can approve the loan or not. So basically what we are trying to do here is find out new variables, such as, I don't know, how long do people come from to go to your store? If you've got a very nice footprint, let's say, maybe means that your store is really interesting, so people really want to take the bother of going all the way to your store. That's something that we might look at, and it might happen that it's interesting, or the average payment in your area, or the recurrence of people in your store. Or if you take all these variables, maybe you can create a new risk rating score that helps us give more credit with less default risk. And that's what we are working in now. Now, if we look at, so that was about trying to improve internal processes and the current portfolio. Then there are other applications which are more classical, such as fraud detection when you are making credit card payments, and it's a very interesting algorithm. Actually, there's people here who created the algorithm, so I'm not going to talk about that. But let's say, beyond those projects that are focused on our current financial services lines of business, let's take a look at what we can do for third parties, what we can do to improve other people's businesses, or just to create new lines of business for us. So first, retail. We started thinking, okay, what does a retailer know about their reality? What do they know about their environment, and what do they know about their business? So they know a little bit about their customers, and then they know a little bit about their area and the sector where they operate, so their restaurant. So they've got that meaning maybe of the intersection of the three areas. But what about my customers in my sector? So what do my customers do when they go to other restaurants, or my customers in my area? What do they do when they are close by my restaurant but they are not buying in my store? Non-customers in my area, non-customers in my sector. This is really interesting. How can I drive people that are not my current customers into my stores? what can I do if I understand better what do my customers in other sectors and areas? So when they are not going to restaurants, but when they are buying fashion, maybe in some other places in the city, is that happening? I might want to do something about that with reaching agreements with other people. So basically, there's a lot of questions that lead to a lot of possible opportunities for those businesses to improve their current results. And we thought, okay, maybe there's something that we can do to solve those questions, since we have that data source that describes so well the economic activity. So we started out with some early explorations, of course, and what we did was, I'm just going to show you some of them. For example, we take for a chain of stores, we compute the average distance that their customers travel to go to their stores, and these are the stores plotted in the map around Madrid, and in each store you see, or maybe you don't see because you're far away, the average distance plotted. And if you understand, let's say, the circle of influence that each store has, maybe you can improve the way that you have designed your retail stores chain. Maybe you can decide on expansion. Maybe you can open a new shop. You can make it more efficient, and you can probably, in the end, provide a better service to your customers. We can have a look at some other perspectives on the same data. So we can have a look at what is the recurrence of customers in a given store or in a given chain. I don't care. Which is, by the way, this is not big data at all. This is just a bunch of numbers. But if you say, okay, let's have a look, and 50% of my customers come just once to my stores in a given period of time. 19% come twice, 9% come 3 times, 5% 4 times, and so on. And this is some numbers that maybe are not so interesting. But what happens if we compare them? If we take those and we cross those with the distribution of spending per recurrence level? So we'll see that the 57% of customers that come just once just bring 26% of the income to the stores. And more interestingly, the 9% that come 3 times are actually 13%. The 5% that come 4 times are 10% of the income. So maybe this means that you want to make sure that your customers come back. Because if the more they come back, the more they start spending, or the more they represent in the average spending in your store. If we had found through these numbers that the people who come just once to your store actually represent 90% of your sales, 95, 80%, I don't care, then you could just make sure that they buy something when they're in your store, and then you just kick them away because they're taking time of your precious salespeople. Because they're not really going to come back, right? So this also can help you influence the way that you're managing your retail stores. We applied another perspective on the data, and we said, okay, what's not the market share, but what's the share that you have in your customer's wallet for your type of activity? So out of every 10 euros that they spend in restaurants, how many do they spend in your chain of restaurants or in your restaurant? So we looked at these figures for a chain of shops according to the postal code where customers live. And it turns out that for this chain, people living in the southern zip codes of Madrid have a higher share of wallet, let's say, with that chain. So 18%, 14%, 14% again, 16% of what they spend in restaurants, they spend in this chain. Now, people living in the city center, they spend very little. So what can I do? What can maybe I want to push up the numbers. Maybe I want to push up the figures in the southern zip codes, or maybe I want to improve my results in the city center. So now I know where do I have to direct my marketing campaigns, which I didn't know really very well before. We can look at the classical market share by zip code, and we can do this, let's say, by default for every business type. And again, this is for the same customer, and what we see is that in the city center, the market share is even lower. So people who, when you go to eat to the city center of Madrid, you don't go to these restaurants. You go to some other restaurants. It doesn't matter where you come from, right? So if you combine both things, maybe you can start also, you can both do marketing campaigns at your store according to the market share, and then you can do marketing campaigns at the origin of the customer according to the share of wallet. We can also have a look at the patterns of consumption. Since every store is categorized as one specific type of store, if it's a shoe store, it's a fashion store, it's a groceries, we can have a look at what do the general population spend their money in, what's their general spending pattern, and here we looked at the Madrid population, and I'm sorry I have this graph in Spanish, probably you don't even see it from there, but what we see is that the first category, it's groceries, it's more or less the same between the general Madrid population and the customers of a given chain, but then the next category, Madrid population is spending, the general is spending in transportation, but then customers of that chain don't spend a lot in transportation, so transportation is much less important. But maybe customers of that chain, they spend more in fashion and shoes. So they might, I mean, if they're in fashion and shoes, they say, we are not doing that bad because our customers are more interested in fashion, and maybe this means that we can, I don't know, we can push more, or we can actually combine then these patterns with the origin of the customers, or we can combine them with any other demographics that we might have about customers. So this can again inform them on how to design, let's say, their portfolio of products and services, right? We can also look at what do people do before they go to your stores and after they go to your stores. And well, this is another graphic of people that it doesn't really tell you much. That spaghetti drawing, but maybe you could see something interesting here. I cannot really tell you very well. There's in the 3 hours before, people like buy things for their homes, and then after going to this store, they don't buy things for their homes. We also did this for a restaurant chain, and hopefully enough, after going to your restaurant, people didn't go again to restaurants, which would be a really bad sign. So all those experiments in the end start driving exciting products, which is what I said earlier, because based on all this, we said, okay, this really looks like it has some potential. This really looks like it could be of value to someone, right? So we are now in the process of, based on all that data and based on all those types of analysis, now that we have experimented and learned, we now know that we can start building things like a tool for retailers that basically automates all the analysis that we have been seeing, and this and makes them available for every retailer, right? So that they can start improving their management. And we can do more things. I'm going to talk now about another line of trying to find a value out of our data for third parties, and it's urban data services. Since our data describes, yes, the commercial activity, but if you don't take the focus of a specific store or a specific chain, but you take the point of view of the territory, then this data is telling you how the territory behaves, how the people that live there are, what are the dynamics of the territory, and so on. And we can do this at several geographical scales. So for example, we can take a pattern of consumption of different countries in the world when they come in Madrid, when tourists come to Madrid, what they do. This is a report that we did with the Madrid City Council, the Information Bureau, the Touristical Information Bureau. And well, it's for this time it's just a graph, but it's interesting to them because you can put that, we can combine this with all the analysis that we've seen before. So maybe we know that the people coming from North America like to buy shoes before they go to this specific type of store, and so on. And this can help the Touristical Information Bureau design a better marketing campaign to attract tourists, or to provide better urban services, because now they know that they need to have people that speak English at these specific points in the city at these specific times of the day. If we take it one step down, we can make an analysis at a country level. And in this case, for example, we just plotted the regions that are the, let's say, the sources of money, and the regions that are the destinations of money. And its sources of money are in dark red, and places that take all the money, let's say, where the money goes, are in blue. And basically, blue points are, except that one that is in the middle of the sea, which is an error in the data, just don't look at that. There's two in the middle of the sea, actually. Maybe the money goes from there and goes down there. I don't know. So the other way around. So basically, you see city centers, because city centers are let's say the aggregators of all economic activity. So money goes there. But if you take this at a dynamical scale, or you take this at a different temporal level, you make zoom in into some specific region, then you might start looking at how money flows, and that might be of interest. Actually, we did that at the same regional level, country level, and we plotted another video that maybe some of you have already seen. We plotted all the transactions made by our cards during the Easter period of 2011, and we plotted in blue groceries, in yellow gas stations, in pink fashion, and in red bars and restaurants. And we see all the activity going on through starting on Monday in Easter week. So Wednesday, which is the day before the first holidays, there's a spike in groceries because people know that next day they are not going to be able to buy groceries. There's also a spike in gas stations because people are like taking the car to flee Madrid and go to the coast. On Thursday, you still see some activity in groceries because it's not a holiday in several regions in Spain. But then on Friday, you only see restaurants and gas stations. There's nothing else because shops are closed. Actually, you see much more restaurants because people are on holidays and they just wanted to enjoy with their families. On Saturday, you see again a big spike in groceries because people didn't buy groceries for some time, and so on. So you basically see what you expect to see. I mean, I'm honest about this. This is not really something that, oh, we discovered something completely new. No. But what this proves, in a way, is that you can trust your data if you do things right. If you have properly cleaned your data and if you have properly, let's say, categorized your data, then you know that the description capabilities that it has are going to help you derive some value from all that, right? And again, if we take this into a different temporal level, into a different geographical level, these dynamics might show something of interest to you or to some organism. Then we take it a notch down, we can go to the regional level, and here we were looking at what the region of Zaragoza looked like. This is another town in the northeast part of Spain, approximately. And if you look at the spatial relationships between the different towns based in the economical relationships, so people who live in Zaragoza, where are they buying in the nearby towns? Maybe this is of use to the city town hall of Zaragoza and other city town halls, and maybe they can redesign the way transport lines are designed, because of course they can look at the data of their transport lines and they will know which lines are most used and which lines are not used, but maybe they don't have lines where people need them. And with this type of data and many other data sets like phone calls and Twitter, and there's so many things that you can use today, this type of data, you can start combining all that and generating new knowledge that could really improve the way that these things are designed. This is more or less the same thing. We made an analysis focused on Sant Cugat del Vallès and the relationships within this town and other, Barcelona and all that region around it. And again, you would see some clusters that form naturally that don't necessarily correspond to how we humans have divided our territory geopolitically. This is a graph, a very complicated graph that really is not maybe very suitable for this screen. But anyway, this is a graph that just shows the origin. So in the columns, you've got zip codes in the area of Barcelona. And the lines that go from one zip code to another one means there was a purchase made here, and then there was a purchase made in another zip code. And you basically see all these connections. The interconnections on the top are between zip codes of Barcelona to zip codes of Barcelona. And then in the down, these other regions that are densely interconnected are also like towns that are contained within themselves. But then you see some things going from one side to other, and they are basically people moving from one town to other towns. And then you also see some strong links. This is just, I mean, you will not work with this graph, of course, and you will not work with the previous graph that we were looking at, but these are just tools to help you in your initial explorations to understand what the value of your data is and what can you describe with that. And once you have that, and once you have thought out your algorithms, then you can put it in your big data systems, because there's tons of data there that really needs power to be mined. But before that, you need to understand what you have. If we go a little bit down in our scale and we just look at a city, again looking at Sant Cugat del Vallès, you can know what their residents are buying within Sant Cugat del Vallès and what their residents are buying outside Sant Cugat del Vallès. And this might be of interest for the city town hall. I see so many shopping malls opening all the time in every city, and maybe you should know that your citizens are not going to use that shopping mall because for whatever reason they commute all the time every day to a city that is 10 miles away where there is a shopping mall right next to where they work, so they are not going to go to the one that you are trying to push now. So don't spend your very scarce resources in doing that. Maybe you can improve some other things. And maybe all this data, combined with so many other data sources, can help you in improving that. You can also use all this data going to a different scale to understand what is the impact of an event. And I think that this was already discussed in another talk previously, so I won't say too much about this, but we did some experiment in these gay pride festivities in Madrid. We looked at the financial impact, if you want, how the commercial impact of the festivities. In the area, the top left corner was the area precisely where all the events were taking place, and from there we were just expanding the area bit by bit to see how the effect spread around. And the thing is that here we are comparing, well, the comparison week 2011, event week in 2011, and event week in 2012. There is actually some improvement. The increase in 2011 over the control week. In the area where the festivities take place, it's 10% of an increase in commercial activity, 4% in the next area expanded, but then when you go a little bit further ahead, it's really big, the effect. It's 20% improvement during the week of the event. So you can actually now say that, yes, this event is actually bringing money to that region. And of course, we could see if, while it brings money to this area of the city, it's deducing money, if you want, from other areas of the city. But we can look at this again, looking at the origin of people. Where do they come from? Are they coming from other towns? Are they coming from other countries? What types of goods are they buying? What types of goods are improving their sales during the festivities? There's just too many perspectives to this. So basically, it needs that you try to understand what is the problem that you want to solve when you want to look at this data. The increase, well, there was also an increase in the event in 2012 versus the previous year in almost all the areas. And this is just a plot looking at the street level of what the activity was, the redder and the wider, the more activity there was. And in these colored patterns, you see if it was a positive change or a negative change or what. So this was just a sample of different explorations that we were doing. And in this case, we are also trying to figure out what is a data product that we can come up with based in all these that will be of any help to a infrastructure manager, a city town hall, any public administration, and so on. So one thing that we noticed during the whole process is that, of course, we are a bank. We are not software developers, and we are not, we are not public institutions that manage cities, and we are not retailers. So in the end, we come up with a set of ideas, but our set of ideas are limited always. So we started thinking, what if we really open this up? What is the way to make the most out of our data, right? I mean, especially when we think about bringing it to third parties, especially when we think about how are we going to derive value for others. So we thought, well, maybe we could become a platform. Maybe we can do something and people will then build on top of our capabilities. And this is basically what we are doing just now. What if we create an open data API? A data API that will expose our data capabilities so that third parties, people that know much better their domain than we do, can build their own solutions for their own problems. Or maybe a systems integrator can bring their knowledge of different sectors and create a product that will be compelling to many other areas, right? So this is what we are doing now, and actually we are launching an open challenge in these days, which is just one step towards our strategy to create this let's say, this open innovation flow, where third parties will be the ones that will be actually making the most out of our data, not just us, right? So actually, today there's a workshop in this conference. I hope that all of you signed for it. I don't know. I don't think that you actually fit in there, but it doesn't matter. It's really exciting and interesting. You should visit room 8 at 5 p.m. today, and I'm telling you that you're not going to be, that's going to be really interesting for all of you. And then I just wanted to say one more thing, that I mean, through this open process, of course, it is the way that we believe that this is going to be expanding, and we really encourage you all to try that. I know it's difficult, but if you do the early experimentation, then you can convince people to give you more money and then to get to this point. But beyond that open model, we really believe that this is actually the way to go. And we are now growing our team, so I make an open call here, again, open to any data scientist or any big data specialist or anyone that would like to join us in this road. feel free to contact me. My details are here. Feel free to contact me either here in the conference or later by electronic channels, and we'll be more than glad to talk to you. Thank you.
Thank you very much, Marcelo. Very impressive.
Thank you.
Any questions, please? Yeah, over there, the middle range. Thank you. Please give your name before you ask your question.
Hello, my name is Felipe. Really impressive.
Thank you.
Yeah, I'm amazed. One question is, how do you clean up, this is based on credit card transactions. How do you clean up effects like you're having a promotion this weekend versus the other bank is having this promotion, so I'm using their credit card, and what you're looking at is, oh, sales went down when they really went to another bank.
Mm-hmm.
Thanks.
Thank you. So what we do, we have two different sources of data. I didn't go into that detail, but we have, on the one hand, our own card holders, so cards issued by BBVA, which is our customers buying in any point of sale. So let's say since we have approximately 15% of the market share in the card market here in Spain, we assume that the sample is probably representative enough. It is a little bit skewed, of course, because our customer base is not the perfectly normal population, but we can, let's say, correct that. But then we also have another data source, which is our own points of sale. So the point of sale terminal that is at the store is also, let's say, issued by the bank. So again, we have 15% share there. So we can compare both sources to try and detect that effect. Of course, if it happens just at one store where we do not own the point of sale, we don't know if what is going on is that some rival bank is with their offer that weekend. If you buy with our card, we give you, I don't know, 2,000 points for flying or whatever. So maybe, yes, maybe people are going there. So we have to be careful about that. But the beauty of this is that that would just be another data source, actually an unstructured data source. And you could have your mechanisms to try and find out about that data, because most banks would probably publicize that in their websites, or they would issue a campaign where you could somehow have some machine around gathering all that data, and then you can input that into your system. And when you are trying to compute the effect, for example, of a marketing campaign, or we're just trying to compute the trends, you could say, oh, there is a low here, and there's nothing happening relevant. So maybe it's just that there was actually less consumption. But if you see that there is a low in your cards, but then the competence had this marketing offer, maybe you can try to start understanding that there was something there. And not just looking at the publicity. I mean, you could just look at Twitter, and you could look at, I don't know, so many data sources that you can combine. Actually, we know, I mean, we believe that our data source is interesting, but it's much more interesting if you combine it with other data sources. And this is actually something that we talked about in the workshop this afternoon. I don't know if I answered your question. Okay, thank you.